this. Okay, great. So before going through the items of our meeting, first let me start sharing the agenda so that we can at least go through the way it is structured. Okay, let's see it. So this is the agenda. Today we'll start right now with a brief introduction of the two projects that are here involved. Let's say three, because EuroCC is together with the Coordination Support Action CASTIEL and ETP for HPC, which is the main, I would say, actor today in the scene. So first introduction on ETP for HPC by Michael Malms, and myself, I will introduce CASTIEL as the coordination action and EuroCC. Then we will go into contents of our meeting. So the white paper made by ETP for HPC, Gabriel, Antonio, and Hans Christian Hope, they will illustrate to us the white paper towards integrated hardware software ecosystem for edge cloud HPC continuum. Then we will move to another big topic, which is what is the continuum between edge and HPC, and how edge computing can support the introduction of industries in the use of HPC. We will also touch the Transcontinuum initiative, and this will be the other topic managed. And finally, we will have half an hour restricted discussion among dedicated to EuroCC and ETP for HPC, in order to, go a little bit in depth and try to see which could be further cooperations among the projects. So our speakers today, I also mentioned Michael Malms, Gabriel Antonio, and Hans Christian Hope, but we also have Sai Narasimamurthy, and again, Michael Malms will go on the Transcontinuum initiative. So as the time is tight, I will definitely leave the floor to Michael Malms in order to briefly introduce ETP for HPC, and then I'll go on with EuroCC and CASTIEL. So Michael, please, when you're ready, you can take the floor.
Yes, thank you very much, Luisa. So my name is Michael Malms. I'm working in the ETP for HPC office, and I'm very happy to give you a little overview of what the ETP for HPC is today, and also give a little introduction into this Transcontinuum initiative that we started a year and a half ago. So I think, Luisa, you need to make me the host in order for me to share the screen. Let me see if I can do this.
Let me see.
You need to activate me.
Can you do it right now? Otherwise, let me see. Okay, it works. Great.
It works. Okay, good. So let me make this full screen. And the question is, do you see? Yeah, do you see the full screen or do you see the split screen?
Full screen.
Full screen. Great. So this is as designed, as it should be. Okay, good. So ETP for HPC in a nutshell. The term ETP for HPC means European Technology Platform for High Performance Computing. So you can imagine that we are very much focused on promoting high performance computing in Europe. So what is our main goal here? You could say we are an industry-led think tank, and we are promoting, this is our to-do, promoting European HPC research and innovation. in order to improve the European competitiveness in this field. So our members, we're having over 100 members by now. I have a chart on this, coming from the private sector, industry-led sector, and from non-profit associations. So we have research centers in there, technology providers in there, and universities, over 100. And we are, for you, of course, you know, Euro HPC, and we are on the private side of the advisory board on research and innovation, together with BDVA and Quick. We have been started the Transcontinental Initiative, and you will hear more about this later. So when you look to the Euro HPC priorities, you see here this kind of structure. In the center, it's all about leadership in HPC use and skills. And you have now various incarnations of fields where this comes to fruition. And you see us here, the ETP is on the technology side. So when it comes to doing everything to secure an independent technology path to high-performance computing infrastructure, this is where we play together with the other associations. And this is also where this European Processor Initiative big project is allocated. Then, of course, you have the application side with the centers of excellence. Somebody is moving furniture. Then you have the federation aspects with Jean and Phoenix. The infrastructure is a big item because there are many systems being procured by Euro HPC as we speak. And then there is this education and training part. So you can put us into the technology area, we do issue strategic research agendas, which basically reflect the advancements or the required advancements in this area. Here, our members, over 100. So a quick look means basically everybody who has to do with high-performance computing, either in terms of research or in terms of production, software, hardware, is somehow included here. So we're very happy to be to have been able to attract all these members over the 10 years that the ETP for HPC exists. And now for a final chart. So what is our main mission? What is our daily platform? So it's about, as I said before, fostering the growth of HPC technology. We produce these agendas. There's the 5th edition is coming out in June. So when you go to the ETP for HPC website, you will see the 4th edition. You can download that and you can wait a few more months to get the latest, greatest agenda. This is an agenda that is basically on a technical level, non-political, technical level, explaining what the current state of the art is and what needs to be done in order to tackle the future challenges. And then we give this document to Euro HPC. Euro HPC introduces its own set of documents called Strategic Research and Innovation Agendas. So basically they take our input and then also put, of course, a political spin in this and then create work programs. And we are also consulting Euro HPC in the definition of these work programs and these calls. It's important that we would like to know that we would like to be one voice of the European HPC infrastructure industry in front of the European Commission. So when the European Commission approaches this ecosystem, they are supposed to go through us. So that's our mission. And as I said before, I'm happy to give you a little later the introduction into the Transcontinental Initiative. And we'll have then a final discussion at the end of the session. So thank you very much, Luisa. That's it from my side for now.
Great, thanks a lot, Michael. So I'll take then some minutes to go through EuroCC and CASTIEL. So you should see my screen and now full screen presentation mode. So quickly, EuroCC is a project aimed at creating and putting together 33 national competence centers around Europe in high-performance computing, HPDA, and artificial intelligence. So here are the participating countries. The project is a project of the Euro HPC joint undertaking, and it is supported by CASTIEL as a coordination support action. Actually, I'm here today as CASTIEL because in the work package 2, we're dealing with competencies, and this workshop is exactly aimed at, making competencies circulating across the network of the national competence centers. So the goal of EuroCC is twofold. Mainly to provide a broad service portfolio of HPC and related technology driven services around to industry, academia, and the public sector. So have it as wide as possible as a service portfolio, and have this increase of competencies through the cross-fertilization among the national competence centers on the 3 domains of HPC, HPDA, and AI. The ambition is to have each national competence center as a single point of contact, which enables the end users, so industry, small and medium enterprises, public sector entities, and the academia itself, having this single point of contact, which allows anyway to, get access to the entire network. So to extend the potentiality, the potential, spread of competencies available. And on the other side, being also the single point of contact towards the national ecosystem and enabling such an ecosystem to access to these competencies, and be also single point of contact on the other way around. So enable other end users to access to the capabilities, skills, and services available at the national level. So at the end, this EuroCC project will allow the national competence centers to deliver more innovative services in the future. And the aim here is that the network will add value in terms of, improving the competencies and services available overall through Europe. In terms of CASTIEL as a coordination support action, CASTIEL is aimed at coordinating such network of NCCs. So the role is to mainly allow and enhance and accelerate this improvement in competencies and services available across Europe. And first of all, closing the gaps, because the national competence centers started with different level of maturities, but also, establishes best practices also to exchange and competencies, best practices, success stories in order to improve also the process of cross-fertilization. So more or less it is it. I will close it here also because we want to give floor to the next parts of this meeting. So let's continue with Gabriel and Hans Christian who will illustrate to us the white paper towards integrated hardware software ecosystems for edge cloud to HPC continuum. So Gabriel, Hans Christian, the floor is yours. I'll stop sharing my screen and give you the chance.
Thank you, Luisa. So let me try to share. Okay.
See the screen?
Do you see the screen? Good. And now I'll go to full screen mode and you should see the slides, right?
Right, full screen.
Wonderful. Yeah, good morning, everybody. So I'm Hans Christian Hoppe. I'm a co-presenter together with Gabriel. Our topic, of course, is the Edge Cloud HPC Continuum, and I will do the first half of the presentation. Gabriel will then step in. Just a few words about me. I'm an old-time HPC expert. I've been doing this for 35 years now. Increasingly, I've been involved in cloud and edge discussions, and together with Gabriel, I work in the ETP for HPC SRA working group on the Transcontinuum, and that's how we got started actually doing the white paper that I'll show at the slides here. So first thing, just a shameless plug for the ETP. There's a white paper available, co-written by Gabriel, by me, and 2 other colleagues. And that contains the thoughts that we are going to show you in the presentation in more detail. There also will be in the upcoming strategic research agenda a chapter on basically the same topic. We then call it the center to edge continuum. So one of the surprising things for people that are not in business IT actually is that edge, while it has been talked about a lot, is also a very significant business. Looking around, IDC, one of the big market study houses, has claimed that they predict, and that was an early 2022 publication, they predict that $40 billion, okay, it's a US house, dollars will be spent in Europe on edge computing. And this is mostly hardware, but also some software expenditure. So 40 billion, 4 times 10 to the 10 is a significant part, really significant part of the full IT investment budget. And that shows that in the world of enterprise computing, also social media, gaming, there is really a significant trend to build up the edge and to use it. Scientific users are maybe trailing a little bit, but we'll come to that. Also, estimates are that next year, 50% of the enterprise IT budget goes onto the edge. And also, they predict that in 2 years' time, there will be an 8-fold increase if you count the applications that use cloud and the edge compared to 2020. That is quite impressive. I cite the block on the slides. That's also interesting reading since it shows the IDC position on what kind of different cloud and edge users there are. Okay. We think that edge and the use of edge plus cloud for HPC is more or less a logical step in the evolution. If you look back at HPC in the early days, or not just days, the early decades, these were supercomputers stashed away at renowned centers and universities, only accessible to a rarefied circle of experts. It then caught on really, really quickly in science. So there are, many science domains that totally rely these days on HPC systems to advance their research. The next step then was to get industry and commercial users up. And that was sometimes called the democratization of HPC. And this worked in a way that HPC resources became available to outsiders and then also became increasingly available on the cloud. And if you look today, AWS, Google, and Azure, for instance, if you have the money to spend, they will rent you time on proper HPC resources. And they have quite a number of these resources. So this has made HPC available to many more parties, and industry has discovered it even outside the classical areas like aerospace and automotive. Then the next step now is, with the edge coming up and with integrated distributed infrastructures coming up that move HPC class systems closer to users, we think that there will be many more use cases and many more users, even outside of core engineering disciplines, that will profit from HPC. And many of them will not know that they actually use HPC. And we try to give you an idea by showing you a few use cases. And then Gabriel will talk about the requirements that we see for the evolution, mainly of the software. The hardware is coming big time, and hardware vendors are always interested to be as ubiquitous as possible. But the software ecosystem is really the main focus of our talk. Continuum, digital continuum or transcontinuum. Our view of that is, well, we have this nice graphic at the bottom. So we have what's called intelligent things, or IoT, Internet of Things. These are, well, billions, trillions of devices of very different sizes and kinds that generate data, which is concentrated on the edge. So these are smaller systems, usually co-located with some telecom equipment that concentrate the information. It's further concentrated in multiple steps between actually the edge and then the cloud HPC centers that are called the fog. And then we have the big centers, be them cloud centers, which are a little bit more general, or be them HPC centers. Information comes in, it is being analyzed, being collected, analyzed, compared to models, predictions are made, or actions are distilled from the data coming in. And for these, you need HPC type technology. Even if you only use machine learning, what you are in reality doing is, well, you're becoming a heavy user of dense linear algebra, and these run very well on HPC systems, and GPUs are very nice for that. So an analysis, prediction, and derivation of actions needs HPC steps normally. Well, we've labeled it here, knowledge is being created. This is being used to react. Reacting means maybe shipping down commands or shipping down instructions out to the IoT devices. It can mean other things. It can mean, well, just giving a scientist the necessary data to write a Nobel Prize worthy paper. And then the circle goes on because, well, if you have effected a reaction, you get more data in, you can compare whether the new data shows that everything is in line with what the system expected. Important here is the distinction between edge and the more central data centers, cloud HPC data centers. The edge, since it's physically closer to the users, to the sensors, and to the actuators, can react quicker, speed of light. It can do real-time data analysis because of that. It can help to implement data protection since it's also physically closer, it's in the same municipality or same country as the user. Well, of course, it doesn't have an exascale system, at least not yet there. On the cloud and HPC data centers, you have the large systems, you can store all the data, you can build up the knowledge or the results. So they are needed. Both of them are actually needed. And then in the middle, depending on the size of your use case, you have the fog layers. In the ETP for HPC that Michael has presented, well, there is this concept of the digital continuum, which I've already mentioned, but we have this nice colorful wheel that shows the various disciplines that are all involved. And these are all technical disciplines. And I know that our audience today doesn't come from technology providers, but still I think it is important to show that the digital continuum touches a lot of the different sectors of IT technology development. And we have also in the ETP documents extracted requirements, extracted the problems that today have to be solved with priority. you will see that besides having these 6 colored blobs around the data and compute platforms, we also have cybersecurity as a circle around everything, because clearly we're talking about a distributed infrastructure and security is of paramount importance. Sorry. So one of the use cases we want to show you, and this is the largest one right now, is called the Destination Earth, or Destiny for short. This is actually a huge initiative financed by the European Union, so by the European Commission. It is being rolled out with 3 partners. The ECMWF, which is a Europe-wide weather center, and 2 other partners. What they want to do is no less than create a digital twin of the complete Earth. And you have a nice rendition of the Earth on the upper right. So it is a digital model of what's happening on the Earth in the atmosphere. So all the weather phenomena are being modeled. The oceans and the rivers. So you have a full and detailed ocean model, but you also look at, well, how does precipitation, for instance, influence the rivers? So that you're able to predict a flood, a flash flood, like we had in Germany last year, and like we had in many other countries, many other parts of the world. And the cryosphere is well, the parts of the Earth that are covered by ice, very important part. So they're also being included. And the new bit here is it's a global model, but we also, or Destiny is also pushing the resolution much farther than you have today. So today you have your very accurate weather forecasts, which typically are in the 10 kilometer to maybe 5 kilometer mesh widths. This will be much more precise. The use case will need data from many, many sensors, and these sensors range from satellites to measurement stations to mobile phones. And yes, you can do quite interesting temperature measurements if you tap into mobile phones. And it will also include, and this is why European Union really funds this. It will include models, and they are, of course, a little bit more, well, at the bleeding edge of research of the bio and the anthroposphere. So, well, flora and fauna and the effects that, well, humans have on the Earth. What we can do with such a system, once it is working, is you can watch what's happened. You can do what if scenarios. For instance, what would happen if we would restrict CO2 emission to a certain level, but on the other hand, we would need to install a lot of windmills. How does this affect the global weather? How does this then affect the climate? So it gives hitherto unavailable data to decision makers, political decision makers, on the effect of global actions. But it's also, as I've mentioned, useful, very useful and critical actually, to early on capture the danger of weather, it's mainly weather catastrophes like floods or hurricanes, and then direct the response to that, and maybe even direct ways to avoid the worst when you can, for instance, very precisely predict where a small river will actually flood, and when it will flood, you can evacuate people. This needs, since it's a global scale, it pushes the boundary on resolution, it pushes the boundary also on modeling bio and the human sphere. It uses huge HPC compute resources, huge data walls and data lakes. It needs to work on assimilation of sensors, and the sensor data are totally different. Today, weather prediction uses curated data. Here we will get data from all kinds of systems that is not really clear how it hangs together, and this has to be done in assimilation. And you need what's called urgent computing capabilities, which means if a model shows there's a hurricane coming in 72 hours, then you would request, or you would sequester parts of the system to do a very detailed prediction. And then you would do what if scenarios, what would happen if we evacuate these parts of, say, the Florida coast. And you would need to run much more important HPC tasks. The link down there goes to the main page, and there's a lot of material available. And with that, I hand over to Gabriel for other use cases and the technical discussion. Thank you very much.
Yes, thank you, Hans Christian. Good morning, and without further transition, so let's go to the next use case, which is a use case in the area of precision agriculture. So here on the right, you have the image of a smart greenhouse, where basically the goal is to control the vegetable environment to increase the production or to optimize the production quality, or another goal that the cultivar might have. And in order for this to work, the greenhouse would use models of plants growth, so some kind of digital twins of the plants. But those digital twins, those models, these mechanistic models that would be executed in the cloud, need to be adapted with local data, very precise local data from that reflects the location of the farm, its weather condition, external weather conditions, also the goals of the cultivar. So it requires a lot of data assimilation coming from the sensors that are locally present. This data assimilation and processing needs to happen closely to close to the sensors, so on what you'd call an edge infrastructure, whereas the digital twins of the plants would be executed in the cloud. So there is this joint use of a hybrid infrastructure. It is common to have model drifts in such settings, so automatic corrections of the models would be needed in some situation. So this is triggered by the data, but what is detected in the data, so it's difficult to predict. So overall, in this scenario, we need deployment and execution of a largely distributed workflow that covers the edge of the cloud in particular, and it illustrates the need to deal with unpredictable data dynamics. And we can go now on the next use case.
Yes.
Which here, thank you, Hans Christian, which deals with smart buildings. So here, the goal is to optimize energy consumption for buildings. So on such buildings, you might have a lot of sensors for temperature, for air pollution, also the possibility to have information on the very precise local information on the weather. So here, in order to predict the energy consumption, first of all, it's important to be able to analyze the historic operation data of the building and to incorporate real-time data coming as we go from local sensors in order to control lighting and heating and so on accordingly to minimize energy consumption. So here again, we have some real-time edge processing for this local data, combined with cloud-based analytics that obviously happens in the cloud. And also one important aspect is that we need very precise weather predictions, and this might require HPC resources. So again, we need to deploy and to execute a distributed workflow that goes from the edge to the cloud and potentially to an HPC system. And in some cases, to adapt, it is important to dynamically allocate resources and execute some processing that is triggered by the data, by the changes in the data itself. So, and so I think I'm done with this use case. We had enough examples to try to abstract a bit. So what is the status with respect to all these scenarios? If we look at technology and the status of software, first of all, it involves many fields, HPC, big data, cloud computing, AI, for instance, just to name a few. And in all these areas, there are specific software stacks that have been developed. Traditionally, they were developed separately. And some sort of convergence started a few years ago, but there is some way to go. What is difficult here are some examples of problems. First of all, it is difficult to deploy and to orchestrate workflows across these hybrid infrastructures going from the edge to the cloud. There is a lot of heterogeneity. the various pieces of hardware can belong to different owners. So it involves some issues related to authentication and interoperability. How to ensure security in this context is an open question, and how to operate this flexibly. And now, if we dig into these challenges, I can discuss them a little bit. So we can move to the next one. So, for instance, at the application level, we have workflows that involve both simulation, analytics, and learning. So the programming models need to be to adapt to the situation. It is not traditionally the case, right? So we need to combine different types of programming models and also be able to compose them. So that's a challenge at the programming level. Regarding data, there are many challenges. They could be related to the 3 V's, the traditional V's of big data, right? Expressing challenges. So for instance, for volume, you have historic data, let's say cold data, you have hot real-time data, and you also have virtually infinite simulated data when you combine processing of data that comes from the simulations with the data coming from the real systems. In terms of velocity, there is a challenge as well, because you need to combine different types of techniques like in situ or in transit processing, that is a usual technique in the HPC area, with stream-based processing, often used on cloud data. And obviously, because of heterogeneity, there is the extreme variety, also in terms of data storage formats, data abstractions, and also in terms of semantics of the data. So there is a need for what could be called a semantic interoperability through some shared ontologies, so that the meaning associated to the data could be the same all over the continuum. Also related to the computation, so one important challenge is to be able to execute the workflow, simply to execute computation in such a heterogeneous setting, and so to support a seamless deployment, basically, so not to facilitate things for the user, right, to hide this complexity. And one difficulty is related to ad hoc load variations, right? It is important to deal with reactions to certain events that are triggered by data, as I was saying before, to dynamically reallocate resources when needed, and to orchestrate smoothly the workload between the edge and the cloud and the HPC. Some other related challenges, and I think we are getting close to the end of the presentation, are related to AI. For instance, being able to run AI workloads at scale. Deep learning is not necessarily, so there still is something that is computational intensive and computation intensive, and there are efforts ongoing, research efforts ongoing to make it scale and to make it able to use heterogeneous hardware, for instance, GPUs and other types of accelerators in conjunction with more traditional CPUs, for instance. There are other challenges related to cybersecurity, for instance. They said a lot of heterogeneity, a lot of stakeholders, so this creates issues related to authentication, authorization, GDPR compliance, for instance, and so on. And finally, beyond this, beyond these technical challenges, there are also non-technical challenges, because many communities are involved, and it is important to enable the cooperation between these communities, the HPC community, the big data community, the cloud computing community, the AI, cybersecurity, 5G, IoT, and so on. And it is precisely the goal of the Transcontinuum initiative that Michael was mentioning, and I know he will detail it later. And to conclude, well, this is our final slide. Basically, what we have seen here is that edge computing is a major trend that we are witnessing. That led to the emergence of an increasing number of applications that combine HPC, analytics, and AI, that run across hybrid infrastructures. And to facilitate the use of this computing continuum in a seamless way, an integrated software ecosystem is needed. And this leads to many technical and non-technical challenges that we have surveyed. Thank you.
Thank you.
Thank you very much, Gabriel and Christian. So really interesting presentation, especially because it goes in concrete with the challenges and the problems that you're facing in this continuum. So thank you really for these inputs and suggestions. So food for thoughts, as we say. Yeah, well, we're a little bit late in the schedule, but I think that we can manage this also considering the discussion, the open discussion part that comes at the end. In the meanwhile, before giving the floor to our next speaker, please consider that you can post questions in the chat, and this will be collected, and also they will help also to organize the open discussion session. So if you've got questions, please just drop them in the chat, and we will pick them up and ask the speakers to take care of them. So thank you again to Hans Christian and Gabriel. I will move then to our next speaker, Sai Narasim Hamurti. So Sai, forgive me for how I spell your surname.
No problem. That was very good. It's perfect.
Thanks a lot.
Yeah.
Thanks a lot. And Sai will talk a little bit about industries as users of HPC and the related challenges, especially taking into consideration this continuum that we've witnessed until now. So Sai, when you're ready, the floor is yours. Thank you.
Yeah. Thank you so much. Just checking the time. So thanks for this. So today I'm just going to talk about ETP for HPC's experiences in our investigation of industries as users of HPCs and what are the challenges. Just quickly go to the next slide. So just a quick introduction about myself. I work for Seagate. However, I've been with the ETP for HPC since the beginning, and currently I'm on the steering board of ETP for HPC and also vice chair of industry for the organization. And I've been working with Michael Marms, Hans Christian, Gabriel, and others from the SRA team, and we have been co-leading the storage and IO working group, which is my pet area within the SRA. So I'm going to talk a little bit about this so-called industrial user working group that we created within the ETP for HPC organization. So I'm currently running this. So why was this? What is this? And what we are trying to do here is our realization that industrial use is one of the major pillars in the European HPC strategy. And we set up the industrial user working group with a goal of developing a deeper understanding of the needs of industrial users. And we also realized that ETP for HPC can also be a strong conduit to be a liaison between these industrial users and Euro HPC. And this is in line with the feedback that we got from the commission that, hey, you guys should really think about including these industrial users as part of your plans. So the goal is also to try and address these industrial user inputs into the R&I agendas that we work, that we develop and that we hope will be taken up by the Euro HPC as well. So what has the industrial user working group done until now is we have looked at the overall problem of HPC provision for the industry. And we looked at specific use case examples within the industry. So we started with a certain thesis with some general, understanding of the industrial, what's the problems that the industry is facing within Europe for HPC access. And then we, to corroborate our thinking and to see if we are correct or wrong, we started talking to a lot of companies. We spoke to SMEs, we spoke to various verticals like oil and gas and automotive. We spoke to large companies, HPC centers, ISVs. So we've been having these conversations as part of like our webinar series, for example, during the last 1.5 years. And we are in the process of trying to understand the pain points of the industry with regards to HPC usage. So just a quick summary of industrial HPC usage is, so HPC is typically the forte of scientific communities. We all know that it's primarily for simulation driven science. However, what we are seeing is that major technological societal advances are all driven by the industry and with HPC usage. We see that in oil and gas exploration, things like bioinformatics, genomics, engineering, media and entertainment, finance, fintech, digital twins, you name it. I mean, pretty much most of the verticals use HPC as a tool. They typically have in-house HPC facilities. So the goal of these industrials basically is to building better products and services or optimization of business ops. So that's why the industry typically uses HPC. So what are our observations and in terms of industrial HPC usage, and what are the various major challenges within Europe? So based on some of our discussions, we see that industrials are fairly limited use of HPC in Europe. However, there is a very increasing need and a very increasing desire among these industrials to exploit this HPC. And increasingly large number of players are really wanting to do that. And these industrials can benefit from the availability of the big public HPC machines, be it the Euro HPC pre-exascale, exascale machines, etc. Also, when we speak of industrials, we also speak of SMEs, small and medium enterprises. They need an understanding and knowledge of the usage of HPC as a tool. They know that there is this nice, big, beautiful tool out there, and they really lack the knowledge of how to actually use it properly. Though some of the SMEs are starting to do that, and my colleague Hans Christian will talk about the Fortissimo project a bit later in this slide deck. And the HPC industrials lack strong connecting links with Euro HPC as well. They are doing their own thing. They are trying to develop their own products and services, but they would really like to be included in the R&I road mapping and try to co-develop these big machines and also the R&I research and innovation strategies. So they need to be pulled into this discussion with Euro HPC. And they also need to get a better understanding of the usage of these machines as well. And this was one of our major observations. And that we need to, as a community, as different organizations, we are sitting around the table today, we need to foster and promote this multiple connecting links between these industrials as well as public HPC bodies like aka Euro HPC. So, so this was our summary of industrial enablement from an ETP for HPC perspective. So this is how. So this was kind of our early conclusions, and we did a position paper some time ago, and which is already there on the ETP for HPC website. You can have a look at that. So we want the industrials to. The industrials would like to very actively participate in Euro HPC decision-making process and co-develop the European short and midterm HPC strategy, and in line with their requirements. And industrials would like to engage in co-design for the technology developments by also speaking with other communities like be it Dyro, Big Data, or AIoT, IoT community, and the AI communities. And industrials also can be enabled by communicating their requirements for Euro HPC infrastructures and getting support in accessing these top-level Euro HPC infrastructures for their applications, which will obviously shorten their industrial innovation cycles, time to market. And the industrials would like to benefit from enhanced collaboration and interaction with a lot of players in our ecosystem, and also the management and governing entities for Euro HPC as well. So this is how kind of we can enable industrial users by working through the various bodies that we have in Europe. Like ETP for HPC is one of them, but there's a lot of others as well. So to corroborate some of our beliefs in how industrials can be enabled, and also to learn more about in the real life what's really happening from an industrial usage perspective, we had multiple conversations since this white paper, and it was driven, as I said, by the webinars. So I will present some of our findings and summary, and maybe you can have a think about this as well and see if that makes sense. So we spoke to like very large companies. This is just an example of the kind of organizations that we spoke to. Large companies like Airbus, Leonardo, Thales, and also like very small companies, SMEs like NAG, CASTIEL. We spoke to some ISVs as well, service providers. We spoke to data centers, big institutions like HLRS, CEA, providing services for the industry, Hartree Center. And also we spoke to Gaia X, which is the very large Franco-German cloud initiative, which is heavily focusing on the industry, but also looking for strong links with the HPC community. So we had multiple conversations, and also oil and gas companies like Repsol. So this is what the SMEs are saying. So they need better emphasis on the commercialization of technologies coming out of R&D. So they feel that there is a lot of R&D happening, SMEs are involved, but there should be more focus on commercialization, especially in Europe. So most of the research, most of the R&D just stays within R&D, and they never come out. And there's no big markets created. And there needs to be additional funding venues as well, outside of public funding, like private capital, venture capital, and things like that. So that's lacking. And also what we heard was that, I mean, whenever Europe develops exascale systems, it's not just provision of these big machines to the SMEs, but also there needs to be a world-class engagement model with the industry. So how you provide the service, how you deal with the requirements. So that having this customer engagement model is important. And also the other thing that we heard from SMEs was that building a sustainable HPC industry is more important than just trying to touch the pole. Like we just want to reach exascale before this and that country and this and that, yeah. So we want to build a sustainable HPC industry in Europe, which is probably more important than building just one or a couple of big exascale machines. And there was also some differences noted between exascale class machines and the actual real world HPC. So the SMEs told us that exascale is typically open. They believe will be open and free, and there's going to be transparency, no vendor lock-in, and mostly on-prem. But what they see in the real world is a bit different. That it's mostly commercial or open software, and there has to be 24/7 technical support, and it has to be of commercial value. through the, and it's mainly on the cloud, through the provision of the right amount of having this right engagement model. So they see this difference between exascale and the real world. And also this, they believe that large companies are taking all the value created, for example, through cloudification. So they get a lot of value. We heard a lot about the edge and the cloud, the continuum. So cloud is a big part of the game now in the trans-continuum. So, but obviously because of the economies of scale, so we see large companies will continue to take the value, but what they believe is that somehow the SMEs need to be more enabled, and the belief that an army of SMEs can create a lot more value. So that needs to be somehow enabled. And also they feel that there's very high barrier to entry. So since HPC is mostly the prerogative of large firms, and wider adoption is limited by accessibility challenges, affordability, administrative opaque procedures, lack of skills and awareness. I'll get to that point in just a bit again. And absence of flexibility and security, privacy concerns. And there's also the HPC is seen as a domain of experts. For example, you shouldn't be getting a PhD in computing when you have a PhD in chemistry. So this is some of our observations from SMEs, and also the large companies. They are saying that education in training in some key areas is a big need in algorithm systems, architectures. All of skills are needed in all these areas, and they're finding it extremely hard to get that expertise from new graduates. So somehow we need to address that gap for the industrials. And companies typically in-house, they don't have people who are experts in parallel algorithms out of the box. And they need to continuously update their knowledge, upgrade their knowledge. So they're looking for some good venues in which they can do that. And they're also struggling to convince all their end users to adopt HPC. Some of them do, but some of them don't. And they feel that there is this potential for quantum computing as well. So we asked, there's many questions asked of them. So yes, there is potential for quantum computing, and there are unsolvable problems today in the realm of classical HPC that can actually be addressed by quantum computing. And there were some examples given. And also this edge and digital continuum, very, very relevant. And companies spoke about, as Hans Christian was pointing out, guaranteeing answers in a very short time. And aircrafts, for example, they mentioned that the edge systems are typically very small. So somehow you need to try and think about how you set up your data flow. And data transfer is going to be very important, between all the components in the workflow between the edge and the cloud, and things like 5G and beyond are going to be more critical. So heavy focus.
Sorry
yes.
to interrupt. Another minute more than we need.
Sure. Yeah, I'm almost. Yeah. And this heavy focus on integration with the HPC cloud, HPC and the cloud, and even the computing centers feel that sustainability is very critical for industrials rather than leading edge technology upgrades. For example, I think these slides will be available. So Hans Christian, a quick word on Fortissimo.
Yes. Yes, so Fortissimo actually is a series of projects, and they started quite a while ago. The current one is called FF4 Euro HPC, and I have just pasted the link into the chat. So Fortissimo projects are about helping SMEs to solve their business problems and to improve their business using HPC. The way these projects work is that we call for experiment proposals, as we call them. An experiment proposal is more or less a small research proposal. An SME puts together a consortium, so maybe an HPC center, maybe some academic experts, maybe a service company, and then proposes a project called an experiment. And that experiment has to address really a business problem or help to increase and improve the business. And then, well, if they are accepted, well, these experiments run for 15 months, and they're being supported by the FF4 Euro HPC team, which actually includes several large computer centers in Europe. And well, then a success story is generated and also used for dissemination. And of course, the SME, if that experiment is successful, profits by having a solution to a business problem. The current project actually has no less than 42 experiments running. So we had 2 open calls. Yeah, the project will not have another open call, but there is the possibility that maybe other generations of this Fortissimo project ideas will be funded in the future. It could be very interesting for NCCs and for SMEs to look at what Fortissimo is doing right now, because there might be other ways to collaborate and to cooperate and to profit. And of course, Fortissimo has already done some targeted discussions with the NCCs. So Lisa, Fortissimo for Euro HPC is being managed by HLS Stuttgart. So we had kind of an interior communication with CASTIEL in EuroCC. Thank you.
Yeah. Thank you, Hans Christian. Yeah, so just the last some conclusions is I think yeah, we need more conversations with these industrials. We need to probably together with the with all our CASTIEL, EuroCC, ETP4 HPC, continue to share notes, and maybe we can have joint workshops with some of these industrials. And yeah, we can, yeah, they definitely need more conversations as well with all the communities in Europe. We should try and enable them, and HPCs need to be bolstered as well. So we all as a group need to think about what can be done to enable them further and provide them access for building links and connections and conversations. So yeah, food for thought on the path forward. So thank you. That's it from my side.
Thank you, Sai, and thank you, Hans Christian. So rapidly, I would just give the floor to Michael Malms. I have some questions to you, Sai, but they will come later in the open discussion. And Michael, the floor is yours for the Transcontinuum initiative, so that we can then close the main session and go to the discussion. Thank you, Michael.
Okay, thank you, Luisa. I will take only 5 minutes because many things have been said already before. So I hope you can put this now on a big screen, and I hope again that you see it correctly. Okay, good.
Yes,
so this is a little update. Yeah, very good. There's a little update. The first page, you have seen this wheel in the middle, so I don't need to spend any time on this. Just maybe on the left side, you see all the associations that were signing a joint vision paper about 18 months ago, saying, okay, we're going to collaborate. This wheel in the middle is basically underlining the important disciplines for many, many use cases, as you have seen this from Gabriel and Hans Christian. And there is a need, an increasing need to collaborate across these domains. So this is a horizontal collaboration effort. And you see all the important, many of the books, many of the important associations today in Europe working together. So what does this mean, working together? One element in this working together is to analyze use case and to understand where are the critical elements and the challenges, and to organize maybe a kind of supportive action for big projects. And I'm coming to that in a second. By experts, by a network of experts coming out of these associations that I talked before. So the ground rule is, let's look at use cases that span this entire continuum, and we focus on digital twin use cases because they, by nature, are using centralized services in the HPC centers and cloud computing arena. They're going over to the edge across the fog, and you have all the incarnations that you see in of technology that you saw on this wheel implemented and required for implementing in digital twins. So we looked at 3 areas. We looked at 3 areas here. One is a real-time digital twin in the industry. Then at extremes prediction, a use case that is very close to what Hans-Christian mentioned in terms of destination Earth. It's basically the idea to predict and to model extreme situation in climate and weather. And then another one in the area of urban air pollution. If you're interested in them, you can go to this website here and download white papers. There are 2 white papers already there. And in each of these use cases, the idea was, okay, so let's understand where in this wheel that you see here on the right lower side, where are the main challenges? And we used a kind of traffic light indication. Red means these are areas where there's a big demand, there's nothing there. This needs to be quote unquote invented. Yellow means, okay, some elements are available, but more research needs to be done. And green means this is under control. I'm sorry, I'm skipping all the time between left and right here. So this is, in all of these cases, this is the outcome of the analysis that we get to this picture, and that we describe these challenges shown here in red, yellow, and green in more detail. The one that we're looking at right now is another one that you might have heard of, the SKA project, Square Kilometer Array. I don't want to spend any time because we are running out of time, but this is yet another use case where you have all these elements from the edge to the center involved. This is a big project that is running already since a few years and will be running for 50 years. So things like reliability, manageability, energy efficiency, all of these things are extremely important here. And the idea is to have a gigantic collecting area for radio signals and to understand better where we all and our globe comes from. On the next page, you see again this kind of spectrum that Hans-Christian showed from left to right. So on the left, you see the edge, then you have different stages in the host countries, meaning in Australia and South Africa, collecting the data, cleaning up the data, and then streaming this to centers, HPC centers in various, on the left, on the right side, in various countries in Europe. You have all the incarnations of, okay, you need to make sure that you use the communication for good data, so cleaning up the data on the path, and then also doing analysis on the data. In the right side here, deep analysis is important in order to understand out of this, let's say, confluence of signals, is there anything I'm interested in? So this is highly interesting. And again, you know, with all the other use cases on the right, you see these are the challenges for that use case. And there will be another white paper very shortly. And there will be a project very soon. There's a proposal being submitted right now. And in this project, if it comes through, we'll have again a TCI community building a kind of advisory board with experts to advise this project around all these elements in this wheel. Okay, very quick. Hans-Christian talked about Destination Earth. You understand what this is. I don't want to spend any time on explaining what Destination Earth is, but I would like to go to this page. So in order to run this digital twin of the globe, of the Earth, there will be, of course, lots of cycles required in HPC centers. And your HPC has been acquiring multiple systems, and this is still in progress. You see this here on the right. There are systems in Finland, in the Czech Republic. There are more others to come. And up to 10% of the union's access time and cycle time of these systems will be spent, this is the European Commission's goal, for extremely important projects, and Destination Earth is one of them. So you will see that it's not only about Destination Earth, it's not only about getting this digital twin defined and running, but also make that the software run over a federated set of systems. And we are here now to organize. We're being asked to organize a consultancy effort, a TCI-related consultancy effort for Destination Earth over the next 2 years. And we're now preparing a response to an RFP where we say, okay, we are interested in organizing this network. And this is all about generating a kind of strategic research agenda or white papers, set of white papers, pointing out solutions and recommendations for specific challenges in the implementation of Destination Earth. And I think this is very exciting. So for the first time, we have all these 8 associations that I talked about in the beginning, collaborate in a very concrete, a very important project for the European Commission. And I'm very thrilled to see this coming up. And I think this is a good demonstration of, okay, if you want to collaborate, then you have an opportunity. And we'll be happy to give you an update once we are running with this project, hopefully starting in September of this year. So that's it, Luisa.
Great, Michael. Thanks a lot. So let me take the opportunity then to thank all our speakers. And I would consider the first session closed, and we can now start with the session dedicated to questions and, interaction among NCCs and EDP for HPC and CASTIEL as well. So I'll close the recording right now.